This video is sponsored by PCBWay.
Our latest X-Wing project was preceded by a design that we started back in January 2024, and it was loosely based on Renee's SUX vertical takeoff concept, and we were looking into revisiting this and preparing this as a 3D printed model. For the basis of the very early design stages of this new aircraft, I used Renee's SUX profile top view as an underlay, and using a sketching app on the iPad called Procreate, I developed some basic early form explorations, and this allowed us to then make some decisions prior to committing to some CAD models. One of the key considerations in the design of this jet was the three fans or ducted fans that you can see in the plan view. We wanted to make sure that the jet was able to take on a VTOL configuration, vertical takeoff and landing configuration, and so the sketching and the styling was fairly much dictated by the position of those three ducted fans. And our exploration here continually tried to find a nice harmonious look to the design. To try and keep in with the feel of our JRM-01C jet, we made sure that the profiles and the proportions of the plane were similar in scale. One area that we weren't happy with was the nose section of the side view of this particular jet, and I prepared some different proportional approaches before entering those into SolidWorks and mocking up and creating some very rough cut SolidWorks 3D models. Here I use surfacing to copy and develop the 2D profiles into a 3D form and generate what we would call our early stage design format or design development, get a bit of an understanding of the layout of the overall aircraft, and this also allows us to make some placement of components so that we can understand where things fit, if they fit, and what we need to do to incorporate them into the overall feel and design of the aircraft. Early 2024, time got rather busy for us, and both Renee and I were caught up with the development of the box wing and the JRM VTOL jet, which took up considerable time, and as a result the development of the SUX 3D printable VTOL jet was put on hold, and we focused on getting the other two projects to market to make sure that they were working and they were available for sale. With the start of a new year, both Renee and I decided to start a new project. We canned the SUX RC VTOL jet and decided to explore a brand new concept for an X-Wing approach and see whether we could develop this into a RC VTOL model. So beginning January of 2025, we began work on very early layout concepts for the jet. Using some NACA profiles, built up the first wing templates and some basic body fuselage designs. In this instance, we skipped the sketching approach and focused more on the elevational views, which we developed up in SolidWorks in CAD. And from there, I spent some time preparing some lofted surfaces and some surface transitions for the layout of our new X-Wing design. When we're exploring the overall shape and geometry of the design, we're keeping an eye on the three ducted fans that we wish to incorporate for a vertical takeoff and landing configuration once again. Here the cylinder represents an area where the fuselage transition needed to be flat enough to give us a nice clean cover style and design. If the fuselage wraps too far around the sides of that cylinder, we know that the cover will be a very thick element, and therefore we're trying to focus on making sure that that area stays nice and level and flat. Have you ever had the need for a fast response solution for prototyping or small batch production run on a design or mechanical project? Well, PCBWay may be the answer for you. PCBWay offer a quick turnaround and superior quality on a range of rigid and flexible PCBs with a focus on prototype runs and low volume projects. But that's not all. Despite the name PCBWay, the company also offers CNC machining and milling services. They also provide 3D printing and a wide range of formats and finishes. Additionally, sheet metal fabrication with laser cutting, bending and post-processing can also be ordered, and should your project require injection molded components, PCBWay offer rapid tooling and multi-cavity tools. With a superb online ordering system, simple drag and drop file uploads and real-time fabrication tracking, make PCBWay your go-to on your next project. PCBWay.com. Throughout the 3D modelling process, I employ the technique of zebra stripes, or the use of zebra stripes, to ensure continuity in the surfaces. In this instance, a lot of the lofting was occurring between three faces, so I wasn't getting the cleanliness and the curvature continuity that I was after. So a little bit of trial and error and exploring different approaches with either lofting the surfaces or using boundary surfaces to achieve what I was after. And here you can see we spend considerable time trying to make sure that our geometry and also the form of our design looks and feels right. Here I'm in the process of joining all the surfaces together that I've created to generate a solid model, and capping the end face and then creating a body onto which I could then cut and shut and create new elements and combine those to evaluate the overall shape and feel of our design. This phase of the design process is essentially digital sculpting. As we're not replicating a design that exists, it's up to both Renee and myself to come up with a shape and a geometry that's both appealing as well as functional. So our main focus here is to not only look at how the elements all fit together, but how they work as an overall design. The design needs to be appealing as well as technically appropriate, and so therefore a lot of energy and effort is spent making sure that we're getting a design that is good to look at but will also fly well. During the design process, we explored probably close to 20 different variations of the design, with changes to the wing transition profiles, fuselage configurations, the front canard configurations. At one point we even explored a different fuselage shape. We called this little design our squashed frog or gecko design. At one point it was even considered making the design for a drone. Here you can see a V-tail configuration. Again, our squashed frog approach, which we weren't too happy with, but my focus at the time was also on the outer ducted fan transitions and softening of those areas. We did focus and decide on the tapered fuselage for the subsequent designs, which led us to this particular variant, and the introduction of the grates towards the rear for the inflow, as we weren't using normal intakes in this particular design. This was going to be a design feature that needed to look appealing and attractive. I decided the round shape wasn't appropriate for the design of the aircraft or the style of the aircraft, so I opted for some more boxy looking intakes, which then led us to our final configuration. Both the canopy had been resolved, the skids now more integrated. We included a hand launch grip feature on the underside of the fuselage, and a lot of the surfaces and the transitions were optimized. Here in particular you can see the lower intakes smooth, similar to the upper intakes. They all flow with the form, and the shapes complement each other and are harmonious in the overall design of the aircraft. One of the unique aspects of this particular jet was that we were working with a thrust vectoring assembly that didn't work on intakes from the front of the aircraft. As you may have noticed in the earlier images, we've decided on areas where the EDFs can draw air from the outside of the jet through a very close ramp arrangement or duct arrangement at the rear of the jet. And here we were looking at a concept that Rene had considered for vectoring the thrust not only at the yaw level but also on the pitch level. So the concept was to develop some unique thrust vectoring that allowed this jet to be optimized for both a CTOL variant as well as a VTOL variant.
And here we got the first parts printed. Main fuselage part. Ribs looks wonderful. Very less stringing. Here the Bambu Lab already finished. Big front fuselage part. Here we got vertical tails, and also one wing is already finished. Looks wonderful. And the nozzle with the whole rear compartment. Let's see. And the largest part just getting ready. Looks wonderful. Just amazing. Love the grips. All the details. Just a little stringing. And also one of the 4 wings is getting ready. This printing with 4% infill. This is, I think, with just 2 to keep it lightweight, and the wing needs a little bit more stability, especially for torsion and bending. So here's 4. Removing the support here from the end works really nice and easy. Just peels off. Very nice. In one piece the support. This part looks amazing and really lightweight. So while the last PLA parts still printing on the Bambu Lab, we can take a look on the lightweight PLA parts and also on the Technic, what we need here. We start with the carbon rods and tubes, 4 mm, 1 rod, 1 tube. Then these screw set, these self drilling screws, self-tapping screws. All you see here will later on be posted also on the part list. The battery, 4S and 1200 milliamps. Then a connector, these XT60. Then we need our 2 BL Heli ESCs, 45 amps. Here is the gyro and the 40mm EDFs. I think this time they are from they with 5000 kV. And we got our BEC, the servos, and 8 magnets. And that's all we need additionally to the lightweight PLA parts. So, and I think we can take a look on the weights. The nose, about 15, with fuselage 33, and fuse 3, 64. And now the biggest one. Let's see what this is. I think under 100, hopefully. So, let's see how it stays here. Yes, 81. 81 is quite perfect for this big part. And also the wings can be checked. 21 on the front and the rear. 18, but this is printed just with 3% infill. That's a bit too less. So 21 grams. 21 grams like this one. Yes, 21 grams is fine. So I will start here from the rear to the front, because it really stays nice on the flat table, and then go with the next and the next and the next, build up the small tower. And here we don't need any positioning pins on this side, but on the next we will need them. Here 4 pins on the next part, and the front one can easily be bonded without any pins. Here we got these rails installed, so super easy. And last part of the fuselage are these rear booms, these both also with pins. And here it is, fuselage of the JRM-02C40. Looks just wonderful. All these details, even without panel lines. Also here, wonderful grip for throwing it later on. I really like this. Also we designed a new hedge close mechanism without any magnets. Just push it with the nose there and then push it down, and it clicks in and holds itself. Really nice. I love it. And the C50 CTOL. 239 fuselage assembled. And time for the wings. They also got these rails, so super easy. Just put some plastic film underneath when you bond it, but you don't bond it with the surface. Press it and done. And next is the wing fans and also the magnets, and the wing is ready. It looks really special, this wing. Go on with the power plant. At first the 1.5mm carbon rod will be installed to put on the linkage for tilting it, for elevator vector. After this, the 2 EDFs will be pushed in and this plate will be screwed on top. And the yaw vector servo is installed as well. Looks super nice, lots of deflection. I think this will get a nice yaw momentum. This is how I finally came up with the power plant. I put some wire extensions to the motors to save some weight, also with these 3.5mm plugs, and connected directly to the ESC 45BL Heli, and using here these 30 amp XT plugs. And here I built up a Y cable with 60 XT to 230 and also included with the BEC. And the length are, as we can see here, between the EDF and the ESC is about 25 centimeter, and then again from the ESC to the battery would say 28. So altogether a bit more than 50 centimeter in length. Before installing the engines, I will go on with the elevator. The servo is already installed with 2 screws secured, and here we got the linkage. It's already pre-assembled. The grub screw is installed in there, and here the 1.4 millimeter self-tapping screws, and this will be slided in here. This works really nice. Just slide it here up to the end. Linkage is in place, and also the rod is running through. Just came out a very little bit, half a millimeter, I would say, but it should be visible and also feelable that it is through. And now we can put on the servo linkage. So servo is on 0 and the arm is straight vertical. This is how it works. The fine adjustment on the elevator can be done by the grub screw, which is easy to reach through this hole, the 3 mm grub screw. This is for setting up the EVD, the 0 position of the elevator, we will do later on. And here we see the 0 position. The nose from the elevator shows exactly to this edge, the trailing edge from the wing. And in this position we can screw down the grub screw. Okay, last check. Works really nice. The engine compartment is ready assembled. Just this linkage part is not installed yet. This will be later on for final adjustment. But everything is ready and can be put in. And that's how it looks like. The left engine to this right area, and the center the push rod, and here the other engine. The servo wire I will also put here on the left entrance. This has a 20 centimeter servo lead extension on it already, so that in the center we just got a push rod and nothing can get untangled. Let's have a look inside of this visible. In the center there's just the push rod, and left and right are all the wires. Yes, I think this is visible here. Everything is nice and clean. Also fixed with these wire clamps. And now we can check if everything moved closely. I just take the push rod here, push and pull, and this should run easy. Also when we take a look in here, everything should be nice and clean, nothing squeezed. And that's it. And now the push rod can be connected. The screw is already in, but it is not bonded. It's not really connected with the push rod. The servo is on 0. You can see this here, 0. So also the canards are on 0. And now we have to check if this is absolutely horizontal. This should be horizontal. It's good visible when you take a look from the rear. Later on, I think we will also put on one marker here that it's better visible to see the 0 position. And when it's in 0 position, just grab your super glue and put a bit super glue on the end of this fork head and also in this tiny hole. And when the glue is dried, you can see how it works, coupled with the canards. Works really nice. And also see the canards are on the most outer and the EDFs are on the most inner hole from the servo arm. So everything is finally programmed. Let's have a look. We got the elevators. So everything is finally programmed. Let's have a look. Elevators, ailerons. So better to see this way. Ailerons and yaw. So and this is programmed with just 2 elevator servos. This is the only special thing. The rest is super normal, and I'm using on all axes 100% and 35 to 35% expo. This will belong up to you. Let's check vector 0 position. The jet is on a flat table, and this should be aligned with this 90-degree block here, and it's okay. And also yaw is also aligned, so it is just perfect. And 0 position from the elevator is just at the trailing edge from the wing. On the canards, I think this is clearly visible. This is on the root rib. They should touch each other. And for the first flight, the CG will be here. I also did some outside some throws, and this works quite nice when it is on the trailing edge from the first wing. Let's have a look on the weight. So weight is 775. It's quite good. Goal was stay under 800. I think this is done. Let's have a look inside to the electronics. Here we got the BEC on the wall with Velcro tape fixed, and the gyro. You can see the position of the putties. They show about to slightly above, and the 2 ESCs on the sides, and the receiver underneath there. Here is the satellite receiver. Yeah, and that's it. I think everything clear visible. Also, here you can see the position of the small switches to get all the right direction and the right setting from the gyro. I was absolutely surprised how handsome this jet was flying from the first moment. I thought it could be a little bit tricky. I was figuring out the CG by throwing it from the hand, just to let it glide, and so I think I already got a good CG. Was just a bit tail heavy for the first flights, but after trimming it with some lead in the nose, it flies absolutely perfect, and it was so handsome. I was trying to spin it or to let it stall, but this was just not possible. When you fly it super slow and pull full on elevator with 0 throttle, it just is sinking and stays stable on the horizon. This is absolutely amazing. Yeah, here you can see it while landing. The thrust to weight ratio on this jet is about 1:1. A little bit less. The weight is 770 grams and the thrust was about 700 grams. I think this can be a little bit optimized that we reach the 1:1. But nevertheless, it has always enough power. There was never a situation where I couldn't recover it, especially later on when I do these high alpha near to the ground. It flies always super safe. There was never a tendency to get the wing down or to start stalling and crash into the ground. So this is a super beginner jet. This is even just more handsome than the JRM-1, while even the JRM-1 is a super jet for beginning flying. The only specialty I noticed is when you get slower and slower, the jet has the tendency to get the nose up a little bit. Not too much, but get the nose up. So you have to push a little bit, especially while landing, whether you get some more thrust to keep your speed or you push a little bit with the elevator. But the rest is super normal. On the length, on the AL axis, it is super stable and super neutral. The roll rate will be a little bit increased by bigger tail runs. later on, but even with this ones you can see I can fly rolls without any problems. I was also surprised while flying upside down. It is super neutral, you don't have to push or pull anything, just keep your horizon and it stays there, and you have enough power to push it again with a half a loop to normal flight position. So it is a full acrobatic jet, and you can, you can do whatever you want. Here I try spinning. This is full yaw vector, and I think half thrust, but you can see it is not that easy to spin it. But flying cool bits here with the elevator vector and then go on with high alpha is super fun and is super easy, and you never. I was never scared that I will have some spin tendency, so this is flying always safe, even if this jet is quite small. So I can just say it again, this is, if you start flying jets, even if this looks very special, this is a super easy to fly beginner jet. Yeah, it's really super easy to fly, super easy to build, and it looks absolutely amazing. Also flying fast, there was no problem. Here you can see coming in for landing, you can land it in a very small area. I think it is also possible to land with a higher angle of attack, but this was just the first flight, so I keep it easy and safe. And also throwing it, the wind was nearly zero. We had just a very little wind, and you can see it starts super handsome. Yeah, and here I'm starting with the ground acrobatics, when I felt super safe with the jet, and you can see it flying with about 30 degree high alpha is absolutely no problem. I'm using about 60% throttle, I would say, so there is always some safety margin up there to climb up if it would be necessary, and you can fly it in super small areas. You can see here I'm using the yaw vector, for direction. I have to pull a little bit more than on the JRM-1. Yeah. JRM-1 was more neutral in high alpha, but this is even no problem and super easy. You can see flying a cool bit and training on these flat spins. I think this will take some more training to let it look more cool, but this was the first flying day, and I'm so happy with the results. I really couldn't imagine it now when I see the video, that such a special design of an airplane flies so perfect from the first moment. Yeah, I'm so happy with this. I think Mark and I are super proud of our work. I think we learned a lot from the JRM-1 and all the knowledge we could now put in this second jet, the JRM-2, and we couldn't believe it, that it is even getting better. But this was our goal, to top even the JRM-1 and try something completely new. And here we combined the design from a forward and backward swept wing. Yeah, we have both wings on one plane, and I think we got both benefits from both designs in one jet. And it works. You can see it here. It works with elevator, with canards, and these four wings. It's an awesome plane. And you can get it now on our website, aerojtp.com. The full STL or 3MF files for self-printing, and also all the other information you will find there, the parts list, and so on. So visit our website, aerojtp.com, and we see us in the next video. Bye bye.